Okay, this is the district final study guide. Okay, so number one here says, is triangle ABC similar to triangle DEC? Explain your reasoning using both your knowledge of sides and angles. Show your work. Okay, so there's three ways to show that triangles are similar. We can use side, side, side similarity, side, angle, similarity, and angle, angle similarity. So we can show that three sides are proportional. We can show that two pairs of angles are congruent, or we can show that two sides are proportional and the included angle, the angle in between those sides, that pair of angles is congruent. In this case, we're going to be able to use all three of them. Okay. Right away, we can see angles are congruent. We know angle A is congruent to angle D, and angle B is congruent to angle E. So we already have two sets of angles that are congruent. So that's angle, angle. Okay. To check the sides, we'd have to set up ratios to see if the sides are proportional. That means the ratios of the corresponding sides are going to be equal. So if we set up a ratio as 10 corresponds with 20, right? AB is going to correspond with DE, so 10 over 20. BC is going to correspond with EF, so that's 6 over 12. Okay, then AC is going to correspond with DF, so it's 7 over 14. 10 divided by 20 is a half, 6 divided by 20 is a half, and 7 divided by 14 is a half. So we have three sets of corresponding sides where the ratios are equal. So we have three sides that are proportional. Since those three sides are proportional, we could use side, side, side. Okay. And then we could then use one of the angles between one of the pairs of sides as well for side, angle, side. So all three are going to work. So maybe our best explanation here is all sides are proportional. Meaning that the ratios of the corresponding sets of sides are equal. Okay, and then all corresponding angles are congruent. All the sets of corresponding angles are congruent. So all sides are proportional because all the ratios are equal. Okay. All the corresponding angles are congruent because they're telling us they are. A and D, you got the one arc, two arcs, three arcs. All right, number two. For each statement, decide whether you agree or disagree with it and explain your reasoning. So all rectangles are similar. Okay, I'm going to put a check mark here under false. Okay, to be similar, those rectangles are going to have all sets of sides that are proportional, and all pairs of angles are the same. We know all the angles are going to be the same because we know all angles in a rectangle are right angles. Okay, but we can just think of an example here. Okay, here's a rectangle, 2 by, let's say, 5 by 2. We could also then have a rectangle here that is 5 by 3. Okay, so 5 over 5, 3 over 2. Those are not equal, so we don't have ratios between the corresponding sets of sides that are equal, so the sides are not proportional. Since the sides are proportional, the rectangles aren't similar. So not necessarily, they could be similar. Okay, you could have 5 and 2, and then you could have 10 and 4. Those would be proportional. Okay, but sides are not necessarily proportional. They can be, but not necessarily. All triangles are similar. That one I hope is easily recognizable as a no because we've been doing that for 4 or 5 months here. You can have angles that are congruent, and sides might not be proportional. Sides might not be proportional. Angles might not be congruent. Okay. When I enlarge a geometric figure by a ratio of 2, both sides and angles double in size. This is a no. So if we have a small figure and we enlarge it by twice its size, okay, both the sides and the angles double in size. So if we had sides of 1, 1, 1, it would become 2, 2, 2. Problem though, if this is an equilateral triangle, that's 60, 60, 60. The angles here are still going to be 60, 60, 60. It doesn't matter how big you make the triangle, those angles are all going to still add up to 180. So by doubling the size, we're making the sides bigger, but we're not doubling the angles. The angles are staying the same. They're not changing. All circles are similar. Okay, that's going to be a yes, kind of by definition. Okay. All you're doing is changing the radius. Okay. Circles are by definition similar. Squares are also going to be similar. Okay, we know the angles are all the same, so all angles are right angles. All angles are right angles. Are right angles. Okay, and the sides, so if we have a square and the side's 2, this one is also going to be 2 and 2. So if we have a larger square, and if the sides are 5, the other sides are going to be 5. So your ratios here are going to be 2 over 5. I'm going to erase all this. Okay, 2 over 5 equals 2 over 5 equals 2 over 5 equals 2 over 5. And all those ratios are equal, so all those sides are proportional. So all sides are proportional. All sides proportional. Rectangles not so much because you can have different side lengths here. Okay, you could have 2 by 5 and then you could have 2 by 6. And 2 over 2 does not equal 5 over 6. Okay, so circles, squares are similar to each other. So two circles are going to be similar in every case. 2 squares are always going to be similar. This is always going to be false. Some triangles can be similar, some can be not similar. Some rectangles can be similar, some cannot be similar. So sometimes, never, always, always. A girl is 4 foot 6 inches tall and casts a shadow that is 8 feet 6 inches long. The end of her shadow coincides with the end of the shadow cast by a building 140 feet from the girl. Find the height of the building, explain or show how you found your answer. Draw a picture. Okay, so first thing I want to do here is I want to convert the 4 feet 6 inches and the 8 feet 6 inches into feet. So there are 6 inches here, so there are 12 inches in a foot. Okay, so 6 inches is going to be half a foot. So these numbers are going to become 4.5 feet and 8.5 feet. Okay, it's not 4.6 and 8.6. It's 4 feet 6 inches tall. 6 inches is half of a foot, so it's 4.5 feet tall, 8.5 feet tall. This is 8 and 6 out of 12, 4 and 6 out of 12. Okay, so we're going to go with 4.5 feet and 8.5 feet. Okay, let's go through again and draw our picture. So a girl is 4 feet 6 inches tall, so 4.5 feet tall, and casts a shadow that is 8 foot 6 inches tall. So she is 4.5 feet tall, and she casts a shadow that is 8.5 feet long. The end of her shadow coincides with the end of the shadow of a building 140 feet from the girl. So you have so here's the girl. Okay, here's the shadow, or these are the sun's rays, so it casts a shadow that's 8.5 feet long. She's 140 feet from the building. Okay. And we want to find the height of this building. Okay. So we want to find the height of this building. So here's our building. Okay, this is our building. Some windows or whatever. And here's our height x. Okay. So these are going to be right angles. Okay, and they both share this angle right here. So we have angle-angle similarity, which tells us those two triangles are similar, right? We have two triangles. We have the small triangle and the large triangle. Let's redraw them, though, just to be safe here. So there's the big triangle. Okay, that's this big one here. The height of that one is x. Okay, the base of that one is 140 plus 8.5. The base of this is 140 plus 8.5. 140 plus 8.5 is going to be 148.5. And then we have our small triangle here, which is 4.5 and 8.5. So we can set up our ratio. So x corresponds with 4.5. Okay. And then equals 148.5 over 8.5. Okay, we cross multiply here, so we get 8.5x equals, I already have one. Okay, 4.5 times 148.5. $668.25. Okay, and we divide by 8. Okay, we get 83.5. Okay, and that's going to be feet. Okay, so the height of the building is 83.5 feet. And we kind of check to see if that makes sense. 4.5 is about half of 8.5. The height of our building, 83.5. I mean, that's about half of 140-ish. So looks like we got approximately the right answer. So 83.5 feet. Let's round to the nearest tenth. We did round to the nearest tenth, so we're good. All right. Number 4, a family picture. Probably should have downloaded this first. That's fine. Okay. Family picture is 4 inches wide by 6 inches in length. If you want to enlarge the picture so that the new length is 14 inches, what will the new width be? So here's our original. Width is 4, length is 6. Okay, we want to enlarge it, enlarging it. Okay. The new length, so this was our length, so our new length is 14. What's our new width going to be? So here's our two pictures. So 4 corresponds with x, so 4 over x, 6 over 14. We cross multiply, that's 6x, 4 times 14. So that's 28 times 2, which is 56. Okay, so we divide by 6 on both sides, and we'll get a decimal round to the nearest tenth of an inch. It's going to be 9.3. Okay, divide by 6. We get x equals 9.3. So the width here is going to be 9.3 inches. So this symbol is inch. So 9.3 flagpole casts a 10-foot shadow. At the same time, a 15-foot tree casts a 28-foot shadow. How tall is the pole? So here's a flagpole. Okay, a 10-foot shadow. A 15-foot tree casts a 28-foot shadow. Okay, how tall is the pole? Draw a picture, show your work, round to the nearest tenth of a foot. So x corresponds with 15. 10 corresponds with 28. Cross multiply, that's 28x equals 150. Divided by 28, so 150. It's going to be 5.4. X is going to be equal to 5. So that's going to be feet. So the height of the pole is 5.4 feet. Okay, this is our flagpole. This is the tree. All right, so the tree cast a 28-foot shadow. The pole cast a 10-foot shadow. How tall is the pole? X over 15 equals 10 over 28. Similar triangles, because we're assuming the angles are the same. The angle of the sun coming down is going to be the same, and they're both right angles, so we have angle-angle similarity. Okay, which of the diagrams contains similar triangles? How do you know? Explain your reasoning. So similar is the first column, not similar is the next one. So are these triangles similar? Do not assume angles are congruent unless marked. So here, again, I don't know if it's different if I downloaded this. Let me check the version I have. You can't even see it. Not a good job there. Okay, so do not assume angles are congruent unless marked. So there's no angles marked here. We can't even read these. Okay, this is 6, 10, 3, and 5. So 6, 10, 3, and 5. They don't give us any information on the angles. So all we have is 6 over 10 equals 3 over 5. Okay, so that's going to be 3 over 5 equals 3 over 5. So we have two sides that are proportional, but that's all we know. So this one's going to be a no. All we know is two sides are proportional. Okay, we need another side that's proportional, or we need a set of angles. Okay, is triangle ABC similar to triangle XYZ? Can't read the numbers. Can't do this one because we can't read the numbers. I can't read it up there. You guys can't read it on the paper. Let's just skip over this one. Okay. Is triangle ABC similar to triangle ADE? So here we can. We're given that DE is parallel to BC. So we have two triangles here. The first one is let's draw it bigger so we can see. So here's our big triangle, and then here's the little one. So we have A, D, B, C, and E. Okay, these are parallel. Okay, so first thing we know is angle A is congruent to angle A by the reflexive property. Okay, via reflexive property. We can also use our parallel lines here. We know by the corresponding angle theorem that if we have two parallel lines that are intersected by a transversal. Okay. So there's our parallel lines, here's our transversals. We know that corresponding angles are going to be congruent. So this angle, angle ABC, is going to be congruent to angle ADE. ABC is congruent to angle ADE. Okay, by the corresponding angle theorem, by corresponding angle theorem. Okay, we can stop right there because then we have angle similarity. We have two pairs of angles that are congruent. So that's a yes by angle similarity. So reflexive property, angle A is congruent to itself. Okay, then corresponding angle theorem tells us angle B and angle ADE are the same. We also know these two would be the same as well. We could have used these. Angle ACB and angle AED would have been congruent as well by the corresponding angle theorem as well. But we only need two pairs of angles to use angle similarity. All right, 7. Solve for AD. So AD is an altitude. Okay, we have a right triangle. This is an altitude. That's what we're trying to solve for. So again, to solve this, we can draw out all three triangles and see which ones are, because X is part of two triangles, right? It's part of this small triangle here. That's also part of this other small triangle. So we could redraw those triangles and see which ones correspond, or we can just use our rule. So this is geometric mean. We have an altitude. So if we have an altitude, okay, here's our setup. The two pieces we're going to use are the two pieces of the hypotenuse, which are 3 and 9. Okay, cross multiply, that's x squared equals 9 times 3 is 27. Take the square root of both sides, we get x equals the square root of 27. Okay. Again, if we want to see why we set it up that way, we got to redraw the triangles. So here's one triangle. Okay, I'm going to draw it just like this. Okay, x is the base here, and this is 3. Okay, then we can draw the other one, the bigger one. Okay, can draw it just like this. The base of this one is 9 and the height is x. So 3 over x equals x over 9. Or we can do it the other way. X over 3 equals x over 9. Okay, and then cross multiply and solve. 8 is just like the last one in number 6. So we have a proof here. It's basically the same. First step in proof is you're given. Okay, we are given that DE. Okay, it should be segment DE and segment AC. We know what we're trying to prove should go here, so we know triangle BAC is going to be similar to triangle BDE. So right there, if this is your final and there are 6 blanks, you should already be at a 3 out of 6 without even knowing how to do anything. Angle B is congruent to angle B. It's like looking in the mirror. When you look in the mirror, you see a reflection. That is the reflexive property. So reflexive property. Okay. And then we just said corresponding angles are congruent by the corresponding angles theorem. So we have two parallel lines is given to us. We're given that DE and AC are parallel. Okay, so here's our transversals. So corresponding angles are congruent. We can use either pair we want. Okay. So let's erase this so we can see what the actual letters are here. Okay, but we have this one, so we can pick these two by the corresponding angle theorem or these two by the corresponding angle theorem. So angle BAC is going to be congruent to angle BDE. Okay. And then for 4, what theorem are we using? Well, we don't have any information on sides, right? Our three choices, again, are side, 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 angle, or angle, angle. We don't have any information on sides here, so it can't be side, side, side. It can't be side, angle, side. It's got to be angle, angle. And here's one pair of congruent angles. And then here's a second pair of congruent angles. So that's angle, angle, similarity. Angle, angle, similarity. Okay. So we want a picture, work, and okay, mine's a little out of order. Okay, but we'll deal with it. So this is number one here for the trig part. Okay, a cabinet has a diagonal length of 34.5 inches and a width of 26 inches. You only have room for a 20-inch tall cabinet. Will this cabinet fit? How do you know? So a cabinet is a diagonal. Okay, it has a length of 34.5 inches and it has a width of 26 inches. You only have room for a 20-inch tall cabinet. So we got to do 3D here. Okay. Has the I'm sorry, I read the question wrong. All right, so here's your cabinet. Okay, diagonal length of 34.5, a width of 26, and a length we don't know. You only have room for, or tall. Length, I guess, can be our tall, our height. Will this cabinet fit? We need to see if x is going to be greater than or less than 20. Okay, if it's less than or equal to 20, it'll fit. If it's greater than 20, it's not going to fit. So here's our cabinet. So we have our triangle. Okay, so Pythagorean, we have two sides of a right triangle. We're trying to find the third side. So that's going to be Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. Okay, so x squared plus 26 squared equals 34.5 squared. Okay, 26 squared $676. 34.5 squared is 119. 0.25. We can subtract 676 from both sides. So we get x squared equals 514.25. We want to get x by itself, so we need to take the square root here. There's no way this is going to fit. Okay, so 22.7. X is going to be 22.7 inches tall. So will this cabinet fit? No. The height is, or the length is 22.7 inches. Okay, which is greater than 20. I mean, I don't like how that question's worded because tall, again, this would imply I guess if you're facing it, this should have been the 26 and this should have been the tall, right? If you take it face on. Okay, but regardless, it's fine. Okay, flagpole is 32 feet tall. You're standing 15 feet away from the flagpole. So 32 feet tall. Okay, you're standing 15 feet away. Your angle of elevation, what is the angle of elevation? The angle of elevation is the one going First thing we want to do is label our. We're looking for an angle, so we know this is going to be inverse trig. First thing we want to do is label our hypotenuse. Circle our angle. Next to is adjacent. Across from is opposite. Okay. We have opposite and adjacent. That's going to be tangent. So inverse tangent of opposite over adjacent, so 32 over 15, is going to be equal to our angle. So inverse tangent 32 divided by 15 is going to give us 64.9 degrees. So let's just say 65 degrees is theta. Okay, 65 degrees. So flagpole is 32 feet tall. You're standing 15 feet away. All right, this is the right angle. Angle of elevation is the angle going up. Okay, Jayla is in the environmental club at school. As part of a community outreach program, they are planting trees around their neighborhood. The trees will need a support rope attached to until the roots begin to grow to stand on their own. If the trees are 6 feet tall and the rope has to make an angle of 35 degrees with the ground, how much support rope will they need? Hint, you need 2 support ropes, 1 for each side. Okay. So let's just deal with one. We have a tree. This is my tree. 6 feet tall. Okay. It's part of a, so the trees will need support ropes attached until the roots begin to grow to stand on their own. If the trees are 6 feet tall and the rope has to make an angle of 35 degrees with so here's the ground. Here's the rope we're going to tie to it. So here's the rope. It makes an angle of 35 degrees with the ground. Okay, here's the ground. This is the rope. This is the tree. Right, this is the tree. This is the rope. 35 degrees with the ground. How much support rope will they need? So how long does the rope need to be? So that's ultimately what we're trying to find here. Okay. It's a right triangle. So again, our 3 options are trig, inverse trig, or Pythagorean theorem. We are finding a side. So it's either going to be trig or Pythagorean theorem. We have a side and an angle, so that's going to be regular trig. Okay. Hypotenuse is across from the right angle. Circle the angle across from its opposite. So we're going to use sine, opposite, and hypotenuse. So sine of 35 is going to equal opposite over hypotenuse. We want to solve for x, so we got to get x by itself, which means we got to get it out of the denominator. So we need to multiply both sides by x first. So we have x sine 35 equals 6. We want to get x by itself, so we need to divide both sides by the sine of 35. So we get x equals 6 divided by the sine of 35. 10.5, 10.5 feet, I believe. Okay, but the question asks how much rope will we need? So for one side, it's going to be 10.5 feet, but it tells us we're going to need 2 support ropes, 1 for each side. So this one's going to be 10.5, and then we have this one over here is also going to be 10.5. So we're going to need 21 feet of rope. Number 4. Sumai is standing on the top of a cliff looking down at a boat. So she's on a cliff. She's looking down at a boat. Her angle of depression to see the boat is 42 degrees. If the boat is 12 kilometers away, 12 kilometers, how tall is the cliff? Hypotenuse. Next to is adjacent. Across from is opposite. So we have opposite and adjacent. That's going to be tangent. So tangent of 42 is going to equal 12 over x. Again, we want to solve for x here, so we got to get it out of the denominator. So we need to multiply both sides by the denominator. So x and x, that's x tangent 42 equals 12. Divide both sides by the tangent of 42. So x is going to be 12 divided by the tangent of 42. Just 13.3. X is going to be 13. Okay, and that's going to be kilometers. Wait. That's let me first say that's the right answer here because this is 42. So this side should be slightly bigger than this one. But that's a ridiculously tall cliff. You're in outer space. You're outside of the atmosphere. This cliff is outside of the atmosphere, I think. You're past the International Space Station. Yeah, you're up there. What are you? 3 miles is 5.1 K, so you're like 7-8 miles up. Yeah, that's pretty high. But we did it right. We did it right though. I mean that's the information they gave us. We did it right. But that's just not a practical problem. Okay, triangle ABC has a right angle at vertex C. So C is our right angle. So A, B, C. The sine of A is x over y. Let's draw this a little different. I'm going to draw it down here. I'm going to draw this one down here. Okay, so this is B. Okay, so this is going to be A, B, C, vertex at C. So C is our right angle. Okay. Sine of A, so sine A, sine is opposite over hypotenuse. So that's going to be x over y. Okay. So opposite is x. Adjacent is y. Here's A. So, sine. Sine's opposite over hypotenuse. So opposite is x. Hypotenuse is y. And we want to know what the cosine of B is. So here's B. Okay, so adjacent. So cosine B is going to be adjacent over hypotenuse. So that's going to be x over y. Okay, we know here the cosine of A, the sine of A is going to equal the cosine of B. Sine of A is going to equal the cosine of B. So it's going to be x over y as well. The sine of one angle equals the cosine of its complement. Right, this was the adjacent. For B, this was the adjacent. This was the hypotenuse. So again, just to say what we did here, sine of A, opposite over hypotenuse. So opposite is x, hypotenuse is y. So here's A, opposite is x, hypotenuse is y. Then it's asking what's the cosine of B. Well, cosine is adjacent over hypotenuse. So adjacent to B is x, hypotenuse is y. So x over y. So if the sine of A is x over y, the cosine of B is x over y. And then last part here on the first page, we want to see if these are going to be equal or not. So let's just take in mind here. So it's saying sine of g is 7 over 25. So I'm going to scroll down a little bit. It's telling us O and N are right angles. And sine of g is 7 over 25. So these are right angles. Right angles. So it tells us sine of g is 7 over 25. Okay, we know sine is opposite over hypotenuse. Okay, so here's g, opposite is 7, hypotenuse is 25. So here's two sides of this triangle. We need to be able to find the third side here. So let's label it x. If we have two sides of a right triangle and we're trying to find the third side, we're going to use the Pythagorean Theorem. So we're going to use x squared plus 7 squared equals 25 squared, right? Leg squared plus leg squared equals hypotenuse squared. So that's x squared plus 49 equals 225. Subtract 49 from both sides. X squared is going to equal 176. Okay, if we take the square root of 176, it's going to be 13.3. Oh, it's 625. I'm sorry. 625. I knew something didn't look right. And so this is 576. So square root of 576, which should be 24. Yeah, very confusing. So x is 24. So we have a 7, 24, and 25. That's the ratios of our first set. Okay. We don't know if those are the actual lengths. The actual lengths here could be 14, 48, and 50. Could be 70, 240, 250. We don't know the actual length of any of those sides, but we know that the ratio of those three sides is 7 to 24 to 25. Since these triangles are similar in the problem, it tells us they're similar. The ratios of these sides are going to be 7 to 24 to 25. We don't know what those lengths are. They certainly look larger than these. So maybe this is 14, 48, and 50, and this is 7, 24, and 25. We don't know. We don't know about the actual lengths. All we know is the ratio of those sides are 7 to 24 to 25. So since these are similar triangles, this one is also 7 to 24 to 25. We don't know the actual lengths, just the ratios of the sides. Okay, so we can't answer any of this till we set it up. So just to recap how we set it up, we knew it told us in the problem that the sine of, I got it written here. Sine of g was 7 over 25. So we know sine is opposite over hypotenuse. So opposite is 7, hypotenuse is 25. 7 is the opposite, 25 is the hypotenuse. We then used the Pythagorean theorem to find our third side. And we found it was 24. Since these triangles are similar, the ratio of 7 to 24 to 25 on this triangle is going to be the same ratio on this one, 7 to 24 to 25. We don't know if those are lengths, but those are the ratios. Okay, we can then fill in our chart here. Okay. Sine of g and cosine of e. So sine of g, we know the sine of g is going to be equal to 7 over 25. It was given to us. Cosine of e, though, okay, adjacent is 7. Cosine's adjacent over hypotenuse. So adjacent is 7, hypotenuse is 25. So those ratios are equal, yes. We can see from the ratios being equal, we also know that the sine of one angle, right, the sine of one angle is going to equal the cosine of its complement. And these two angles are complementary angles because they add up to 90. So the sine of g equals the cosine of e. Tangent of e and tangent of g. So I mean, automatically we know it's not going to be the same because you're going to have, they're going to be reverse. Okay, well, let's write them out. So tangent of E, tangent is opposite over hypotenuse, so opposite is 24, or opposite over adjacent. Opposite is 24, adjacent is 7. So that's 24 over 7. And we know the tangent of G is opposite over adjacent, so opposite is 7, adjacent is 24, so 7 over 24. So we know it's going to be no. Sine of U and sine of G. So the sine of U, or sine U, opposite, sine is opposite over hypotenuse, so opposite is 24, hypotenuse is 25. Sine of G, opposite over hypotenuse, so opposite is 7, hypotenuse is 25, 7 over 25. So those are not equal, this is a no. Sine of U, we just said sine of U is 24 over 25. Cosine of F, so adjacent over hypotenuse, so 24 over 25. Adjacent to F is, next to F is 24, hypotenuse is 25. And so that is a yes. And again, our explanation here is the same as it is for the first one. The sine of one angle is going to equal to the cosine of its complement. So F and U are complementary angles. So the sine of F is going to be equal to the cosine of U. Cosine of G and tangent of U. So cosine of G, adjacent over hypotenuse. So cosine of G is 24 over 25. Tangent of U. So U, tangent is opposite over adjacent. So opposite over adjacent, 24 over 7. Okay, those are not equal, no. Okay. Cosine of G, we just said cosine of G was 24 over 25, adjacent over hypotenuse. Okay, cosine of F, so here's F. Adjacent is 24, hypotenuse is 25. So the cosine of F is also going to be 24 over 25. And we notice it's yes, so this explanation is a little different than the first two yeses. This one is because those angles are equal. Right? Similar triangles, so the measure of angle G and the measure of angle F are going to be equal. Those are congruent angles. So if their measures are equal, the cosine of the same angle is going to be equal. Sine of G, 7 over 25. This one's going to be yes. Sine of G is 7 over 25. And then cosine of U. Adjacent is 7, hypotenuse is 25, right? Cosine's adjacent over hypotenuse, so that's 7 over 25. So they're both 7 over 25, that's yes. Right, E and U are congruent. So if G and E are complementary, then G and U are also going to be complementary. So the sine of one angle is going to be equal to the cosine of its complement. So we know the sine of G is going to be equal to the cosine of E. The last one on there is tangent F and tangent G, which is also going to be a yes because F and G are the same angle, right? F and G have the same angle measured. So if we write that one out, they're going to be the same, right? Tangent F is going to be 7 over 24. Tangent G is going to be 7 over 24 as well. Opposite over adjacent, opposite over adjacent. So again, we want to, we started with sine of G, 7 over 25. So we fill in the opposite 7, hypotenuse 25. Use the Pythagorean theorem to find 24. Since these triangles are similar, the ratios between the sides are going to be the same for each of them. So if this is 7, 24, 25, this one is also 7 to 24 to 25, even though those aren't the actual lengths of the sides. But we're just dealing with ratios, so it doesn't matter. And then that is, yeah, that'll be the end of part one. Part two will be next.